This vessel is an unmanned surface vessel built by L3 Harris in Portchester, delivered to us here at the University of Plymouth. This vessel is called USV CETUS. USV CETUS, in Greek mythology, it's a sea monster. In Latin, it's the origin of the term Cetusian, and it also means unafraid of the sea. So this is the boat. The boat is divided into two sections. You've got the engine bay at the back, and then we have the payload bay at the front. The boat is aluminium hull construction, aluminium monocoque, carbon reinforced plastic hood at the back there. See, it's beautifully laid out. It's super neat. They've done an amazing job. It's a 35 horsepower Yanmar diesel engine. It's a pretty standard marine setup, but it's been very, very sort of nicely apportioned. It's a diesel jet drive. It's on a centrifugal clutch. There's no gearbox, which makes it quite a simple system. It's got a big, fat, upgraded alternator here to give you a lot of extra power for payloads. It's got an air conditioning unit for operation in hot climates. Fully waterproofed electronic section, and you can actually operate certain aspects of this from inside here as well, which is quite good for test and diagnosis. This central section is the retractable mast. It's got an actuator here and a great big kind of piston, if you like, that goes up and down, and that's what we mount our instrumentation on. And they're all down here. Under this section, there's basically a large moon pool. So that's a section of the hull that's been cut out. The great thing is that, of course, we can retract that for transit, and then we can lower that when we're in situ and we want to do our hydrography. And that then protects a very, very important asset from damage. This is the payload section where we have the dry payload. So inside this container, you can see we have all of our processors and computers for running our multi-beam and anything else that we wish to put into this vessel. So if we're running ADCP or water samplers, all the coordination for that will be done in this section here. This thing down here, you can see this black box is the waterproof housing for the profiling winch, which gives us the ability to profile in the water column, which is quite a key capability to have if you're doing hydrography. This whole equipment rack here actually lifts out and then folds forward, which is really useful for doing installation and maintenance on our IT equipment. This is the shoreside control station setup. You can see there are various components to this. First of all, we have the helm. That's this device here. That's quite similar to a standard remote control unit. You can use that to drive the boat manually. Here we have the user interface, which is where we do our mission planning. We can control all aspects of the vessel, monitor its performance, monitor all the key systems, and turn various things on and off. And this here is the payload computer, which is linking into the Norbit multi-beam control system that's over there in the payload bay. We've got 4 different ways of communicating the vessel. First way is to plug in via a shore cable, which is quite useful for doing certain high-level diagnostics. We have 3 different wireless communication systems for the boat. The first is this one here. This is the DTC mesh radio network. This is a military-grade communication system and can give us between 6 and 30 kilometers range, depending on the elevation of the base station. We then have a Wi-Fi system here, these 2 white antennas at the top, that can give us a kilometer range. And where we have a 4G cell net communication, these 2 white antennas at the bottom, that can obviously give us control of the boat anywhere within a cell phone coverage area. The way this works, if we lose one, it will seamlessly switch to another one, which gives us lots of redundancy, lots of backup, which is quite a nice thing to have if you have quite a big, expensive boat driving around in the sea. So this vessel has several different systems for situational awareness. The first and foremost is AIS, that's Automated Identification System. That's where all vessels transmit their name and their direction and their speed via VHF antenna at the back there, and that gives us a readout on our chart, which you can't see at the moment because we don't have a GPS fix. But that tells us all the other vessels in the vicinity and where we are relative to them and their speed and direction. We then also have a radar, which is very useful in any sort of low light conditions. And the great thing about this is the radar is overlaid on the chart, so we can see a correlation between the AIS and the radar. We then, of course, have cameras. Now, this is a later edition of this boat. It has 360-degree cameras. So we have cameras forward and aft, port and starboard. And we also have an IR, infrared, night vision camera as well. So currently I can see the forward part of the workshop. If I can switch to the port view, there we are, we can see us there. So eventually the aspiration is to have these on screens all around us to give you a kind of full feeling as though you're sat on the vessel actually driving it yourself. So this here is the payload computer. All of the actual software for running the mission hardware, so in this case the multi-beam, is actually in situ on the vessel. And all we're doing here is we are team viewing in using a remote desktop function into the computer on the vessel, and then controlling the software as though we were sat on board.